So now we're going to go over how to factor polynomials, and we're going to do that with an example. So the way I'm going to do this is I'm going to write out a bunch of general steps that I use when I factor polynomials. And whenever you run into a question of factoring polynomials, you'll always be able to refer to these steps. So make sure you write them down, make sure you pay careful attention, because this is very important in this course and you will be tested on it multiple times. So the first step that we always take is we check if we can factor out anything from the polynomial to begin with. So any common factors, whether that's constants or x variables, and or -1 if the leading coefficient is negative. Well, in our case, the leading coefficient is positive. It's a positive one, so we don't have to take out a -1. And there are no common factors to take out. There's no variables that are common in each term. So step one, we don't have to, there's nothing to do in step one in this case. Step two, find factors by trial and error using the factor theorem. And what does the factor theorem state? Well, if we have a divisor and we divide the dividend by that divisor and get a remainder of 0, that means that that divisor is going to be a factor. So what we have to do is we have to start plugging in a bunch of numbers for x into the dividend and trying to find when it's going to equal 0. So I usually like to start with really simple plus or minus 1. So for example, let's test if x minus 1 is a factor of this polynomial. And the way we would do that, we would find what the remainder would be if we divided this polynomial by x minus 1. So we could use the remainder theorem and just plug in our k value of 1. And if we do that, f of 1, plugging in 1 for the x values, we would get -50. So we know x minus 1 is not, or I'll write it here, not a factor. And then we go to the next one. So we did x minus 1, let's try x plus 1. And if you remember x plus 1, to find the remainder of that, we would have to switch it into the x minus k form. So we would have to plug in f of -1 to see what the remainder would be if we divide this polynomial by x plus 1. Now, if you're not sure why we're plugging in -1 for the x values in the dividend to find the remainder, I would highly recommend you go back and watch the remainder theorem video, as it's super important. You have to understand the process of why we're doing this. So plugging in -1 for the x values in the dividend, we would get a value of 0. And by the factor theorem, that just means that x plus 1 is a factor. Now that we found our factor in step 2, we can move to step 3, and we have to find the quotient when dividing our polynomial by the factor that we found in step 2. Now, I did the division on the side for you, but just so you could practice, you should pause the video and try it yourself. Divide this this polynomial by this factor x plus 1 and see if you get the same result that I did. I'm not going to go through the actual process of dividing, but I did write it down for you just to save time for the video. However, I'm going to label, so this part here was step 3. I did step 3 on the side. I do want to make one note about this step, is that when you do the division, you should always get a remainder of 0 because you're dividing the polynomial by a factor, so it makes sense to get a remainder of 0. If you don't get a remainder of 0, then you know you screwed up somewhere. Usually it's with the long division process, but you also may have miscalculated when plugging in your k value into the dividend, and it shouldn't be a value of 0, hence whatever factor you got shouldn't be a factor. But usually it's the long division that contains an error. So just remember, you should always get a remainder of 0 at step 3. Another point I want to make is you don't have to use long division. I personally prefer to, but you could also use synthetic division. Same thing applies though. Make sure that you get a remainder of 0. So after step 3, we could write out what result we have so far in the factoring process. So we got our polynomial, our original polynomial, and now we split it up into the factor that we found in step 2 and the quotient that we found in step 3. Now we can move to step 4, and step 4 contains 2 cases. So the first case is if the quotient that we got in step 3 is a quadratic, then we just factor the quadratic using decomposition or a quadratic formula. Sometimes even the quadratic won't be factorable, but usually it is. So we can just factor it using techniques we already know. The second case is if the quotient has a degree that's greater than 2, then we just go back to step 2 and repeat the process and factor that remaining quotient. So in our specific case, the quotient that's remaining is a quadratic, so we can just simply factor it. So let's do that on the side. So we got x squared minus 2x minus 24. And if we factor that using decomposition, we would get x minus 6, x plus 4. So this here on the side was step 4. And we're done. So our final result ends up being, so let's rewrite the dividend. So x cubed minus x squared minus 26x minus 24. That's equal to our original factor that we found in step 2. And then we factored this quotient here, so we end up with x minus 6, x plus 4. So this here, x plus 1 times x minus 6 times x plus 4 is the factored form of x cubed minus x squared minus 26x minus 24. Make sure you watch the next few videos, as the polynomials we're going to deal with are going to be a little tougher and they're going to have higher degrees. The steps we're going to follow will be the same. These steps always work no matter what you're factoring, but the cases and the results will be a little different. So go ahead and watch those.